So today I would like to present our Lab 5 RC and RL high pass filter. So name of group members, Nur Najah Hazira binti Azari and Nurul Izzah Hazira binti Ilyas. So we move to the first lab, which is RC high pass filter. So first thing first, we determine the transfer function for RC high pass filter. So we just use this formula, VR over VE, 1 plus J omega over Z. So how to find Z? We use 1 over RC. So we just insert the value and we got 6.447K. So from this formula transfer function, we just insert the value of Z. So next, to determine the cutoff frequencies for the circuit. So for this cutoff frequencies, we just use 1 over RC and we got 6.447K radian per second. And then for cutoff frequency, use this formula and we got 1.026 kilohertz. So next is circuit construction. How to find the output voltage. So connect the circuit to the capacitor and then this to the ground and the channel A. So we set the function generator frequency 2 kHz and amplitude 2 Vp. Just turn on the switch. Okay, how to find V out? So we drag the first cursor from here and then the second cursor to the upper peak. So this is the voltage output that we got, 1.778 volt. Okay, next we just insert all the value that we got from multisim into this table and then find AV, VR over V in, and then AVDB. So this is the result that we got. Next is how to find FC measured. So FC measured, we just calculate 0.7007 voltage maximum. So from this table, so voltage maximum is 1.941. So we got 1.372 volt. So from this multisim, we just set the function generator. So the value that we got, that almost accurate with the voltage output, is 1 kilohertz. So after we fill in all the table, so we just plot the graph. So this is the graph that we did it. So that's all from me. Thank you.
Assalamualaikum, my name is Nurul Izzah Hazira binti Ilyas and I will present about RL high pass filter. Okay, firstly we want to determine the transfer function by using the formula given. And we will determine the cutoff frequencies for the circuit in figure 3 by using the formula given. And then is what we get after we calculate. Okay, next I will demonstrate you on how to measure V out by using multisim. So this is the component that we use for the circuit that we use. So we use resistor and inductor, and also we use function generator and oscilloscope. Okay, now I will connect the circuit. Positive will connect to the positive function generator, will connect to the resistor, and equal will connect to the ground. For the channel A, I will connect to the resistor. In the channel B, I will connect to the inductor. Then this one connect to the ground. Okay, for the connector inductor, I will change color segment to green. The color segment to no difference between channel A and channel B. Okay, so now I will set the function generator according to the table given in the table sheet. Okay, so now I will set the BP. I will set the BP to 2 volt according to the worksheet. Okay, according to the worksheet, this one. And I will take 400 Hz. Okay, I will take 400 for example. So 400. Okay, now I will run the oscilloscope. Okay, after that, I will set up the scale for channel A and channel B. And then I will set up the time scale. As you can see, the graph will become larger as I set the scale smaller. Now, I will change the scale for channel B. Okay, I forgot to change this to AC. And channel B, I will change scale to 200 millivolt because easy to see the waveform. For the cursor one is for the channel A, which is LVN. Okay, so cursor one I will set to the Y maximum. And for the cursor two is a channel B, which is for the V out for inductor. And so I will change the trace ID to the channel B. And then this cursor will go to the next one maximum. Then we can just take the V out from channel B, which is we use for cursor 2. So 204.448 millivolt is the value of V out for inductor. Okay, next we will continue measure for the frequency from 100 Hz to the 10 kHz to find the V out for inductor. To find the value of the V, we will use the formula, which is V out over V in. Then we will get this value, and calculate the voltage gain. We use this formula to get the value. Okay, after that we will plot the data for frequency versus voltage gain. Next, for discussion, the difference between low pass and high pass filter circuit is a low pass filter passes signals at frequencies lower than the cut-off frequency from the input to the output. And for the high pass filter passes signals at frequencies higher than the cut-off frequency from the input to the output. So the examples of band pass filter, low pass filter and high pass filter circuit application in our technologies today, which is low pass filter are used as these filters in audio speakers to reduce the high frequency is produced in the system, and these are used as inputs for subwoofers. For bandpass filters are widely used in wireless transmitters and receivers such as the RFID system at the tools nowadays. And lastly, high-pass filters are used in speakers for amplification purpose. So in the conclusion that we got from this whole experiment is we are able to determine the transfer function and cut-off frequency for a high-pass filter circuit. We also can determine the frequency response for high-pass filter circuit by using straight line approximations of the baud plot and map comparison between the actual frequency response and the approximations of frequency response for a high-pass filter circuit. We have seen that the passive high-pass filter is the exact opposite to the low-pass filter. This filter has no output voltage from DC up to a specified cut-off frequency point, This lower cut-off frequency find is 70.7% or negative 3 dB of the voltage gain allowed to pass. That's all from us. Thank you.